Welcome back, students. Now in this part I'll be telling you about the halogen family, which is the most electronegative element family in the whole periodic table. We'll also deal with the compounds which it form, the chemical and the physical property first of all. So here we go. In this topic, guys, we'll study halogen family. So it starts with fluorine, chlorine, bromine, iodine, okay, and all. So they are collectively known as what? Halogens. And hals means salt in Greek, okay, and genin means to form. So they are actually what? Salt formers. Salt formers. That's why halogens. Now, name of the elements, name of the halogens which are found in the elemental form. The last member of the group is astatine, okay, astatine, which is radioactive halogen, which is a radioactive halogen. How do they occur? Let's have a chart. Now, due to their very reactive nature, okay, they are found in always combined state. They cannot be found in a free state. So, fluorine like cryolite, fluorspar, fluorapite, okay, chlorine like NaCl, MgCl2, KCl, CaCl2, bromine like your bromides of all the alkali metals, iodine as iodides of all the alkali metals. How do we isolate them? So first is fluorine. Obviously the electrolytic method is most importantly used for them, okay, because they only have to accept one electron. So it is the best. So the best method was developed by the Moissan. Okay, he took what? He took potassium fluoride and anhydrous hydrogen fluoride, and he just used the carbon rods, okay, as electrodes, cathode and anode, carbon and graphite, and then passed the electricity. And he observed that at cathode I'll be having hydrogen gas, and at anode I'll be having fluorine. So this is very pure form. This is very pure form. Similarly, chlorine also, it was produced by electrolysis only, okay, and by natural brine. Brine is what? It is solution of NaCl, aqueous solution of NaCl. And in the lab, I can produce it by oxidation with MnO2 of HCl as KMnO4 or by KMnO4. Like this. Here I am having MnCl2 plus Cl2 also getting formed. Or if I take KMnO4, also I will be getting a Cl2. Next, my bromine. Bromine is commercially produced by the oxidation of bromide ions, like this. Here my bromide ions is getting oxidized and Br2 is getting formed. Iodine, if I talk for iodine, it is manufactured from the natural brininess of seawater weed by oxidation of the iodide ion with the chlorine. Again, this type of reaction. This is iodates, sodium iodates, NaIO3. So here I am getting I2 getting produced. If I talk for the chemical properties of halogen, then among all the halogens, you know that fluorine is the most reactive. Okay, and the reactivity, obviously it will decrease down the group. Highest reactivity is due to the electronegativity first of all, and due to the low bond dissociation enthalpy. Also due to small size, it has many effects. Next is oxidizing power. So if I talk about the oxidizing power, so they are very strong oxidizing agents, okay, because they are high, they have high electron affinity. They will accept the electron and make the other one to get oxidized very quickly. So the oxidizing power, it decreases again down the group because your fluorine is the most strong oxidizing agent. So the order will be this, in a decreasing order. If I talk for hydrides, again there comes hydrogen bonding into the picture, okay. So the halogens with combined with the hydrogen to form volatile hydrides have the formula HX, okay. It's like HCl, HBr, HI, right? And here you can see that in HF you have hydrogen bonding into the picture. So its boiling point will increase tremendously, okay. And your order of acidity, again HF will be the strongest. and reducing property will increase down the group because your HX bond strength it decrease. If I talk for the oxy acids, then they form only hydrofluorous acids, HOF type. Okay, fluorine. Fluorine forms only hydrofluorous acid. Rest other forms your HOX, HXO2, HXO3, HXO4. And strength will be observed by, if you go down the group, they will increase. Okay, they will increase. So more the oxidation state, more will the strength. Also, their conjugate base will become more stabilized due to the resonance factor. So this is the order of strength. Okay, acidic strength. And if I made them react with some metal, okay, they form hypohalides. Okay, like CaOCl2. This is calcium hypohalide, you can say. This is bleaching powder. The common name is bleaching powder. So it's formed like this way. And the halic acids are also known in solutions, but iodic acid exists as white solid. So we can say that stability of these acids, it will increase as increasing the size of my halogen acid. If my halogen acid is bigger, then my stability is more. And the salts of these acids are known as halates. Okay, NaClO3 is a powerful weed killer also. Its application as a weed killer, also used in fireworks. And perhalic acids, it form perhalates as their salts. Perhalates. So that's about the halogen family, guys. We'll study more about compounds of halogen family also in the next part. So students, in this part, we learn about various halogen elements, physical and chemical properties. Like we study oxides, how my hydrides vary, how my oxides vary. Now in the next part, I'll be telling you some of the compounds which are formed of the halogen family. So halogen family compounds I will be discussing in the next part. So stay tuned with me for that.